Okay, so we said that you need to lock yourself in a closet and think about this stuff. What should you be thinking about? Well, let's summarize what we've concluded so far. First, to find the confidence level, you need the mean and the EBM, the error bound, through the standard deviation. You need to calculate the z-score for half the area in white from the normal curve. That's when we figure out what they want in the green. Like, let's say they wanted a 90% interval. We do 1 minus the 90%. That leaves 10% or 0.10. Then we divide it by 2 to get two tails, white on either end of 0.05. That's how I calculate the area. Next, I use the inverse norm in z-score mode. That's with the 0 and the 1 in the last two places to find the z-score. Then we use the formula, because I need that in the formula to find the error bound. And then the confidence interval is the mean minus the error bound and the mean plus the error bound. Error bound? That is your error bound measurement. This first symbol here, this means the z-score for the left or whatever the area on the white area is at one tail. And this is your standard deviation calculation whenever we're involving means, which is the standard deviation divided by the square root of the sample size. Now, what we're going to do is we're going to apply this strategy multiple times in a row. And if, as suggested, you watched the previous video twice, and then you've come back and you've looked at this process, to find the confidence level, you need the mean and the EBM. Calculate the z-score for half the area in white from the normal curve, taking away the green area, that's the confidence level. Using inverse norm to find the z-score, in the z-score mode, to find the z-score you're looking for. Use the formula to find the EBM. Yeah, you get the formulas all the time. Use your formula for EBM. That is your z-score answer times the standard deviation divided by the square root. And then to get the final answer, I do the mean minus the error bound, the results of this calculation, and the mean plus the error bound. And that gives me that green on either side of the high point with the symmetry. So that is what we're going to look to do. How do we do that? Well, let's try a few in a row that really helps us understand what this is. Don't worry about referring to the pizza delivery problem from before. Let's just go with this. The mean delivery time is 36 minutes and the population standard deviation is 6 minutes. Assume the sample size is changed to 50 restaurants with the same sample mean. Find a 90% confidence interval level for the population mean delivery time. So this is what we know. Here's a summary. Ready? The mean is 36 minutes. The standard deviation is 6 minutes. And the sample size is 50. Remember your error bound measurement formula. I know my standard deviation is 6. That's going to go in the parentheses on the right at the top. And it'll be the square root of 50 in the bottom. I now need to find the z-score for that half area of white. So 1, namely the area of the whole normal curve, minus 0.9, which is the green area, leaves 0.1. And then I divide that by 2 for the little two white areas on the end, and that gives me 0.05. That's step 1. Step 2, second var's inverse norm. 0.05, the 0 and the 1 are already there for you. If for any reason they're not, then you just quit that mode, come back to it, and clear them out, get them back to 0 and 1. That gives you 1.645. So second var's inverse norm of 0.05, 0, and 1 is 1.645. Now, to find the error bound, I take that answer to the inverse norm, 1.645, and I multiply by what we said before. The standard deviation was 6 over square root of 50. I do that and I get 1.40. The calculator does it all. Look, it's as if there's a magician standing at the front of the stage, and instead of waving a wand and pulling a rabbit out of a hat, he holds his graphing calculator and he presses the buttons. Dun, 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 inverse norm, 0.0501, boom, 1.645, and then you plug it into the formula. And again with the calculator, he does 1.645 times, and then it's always, just like in the central limit theorem, standard deviation divided by the square root of the sample size, 6 over square root of 50. When he does that, out pops the answer 1.4. What you need to know is this. The calculator does all of the previous, does steps 2 and 3. You need to, in your understanding, be able to calculate number 1, find the size of one of those little white areas on either end. And number 2, express the confidence interval. Since the mean was 36, it's always 36, the mean, minus the error bound, 1.4, which is 34.60, and 36 plus the error bound, which gives you 37.40. How do you write the answer? The 90% confidence interval is the interval from parenthesis 34.6 comma 37.4. So that's the process. Let's break it down step by step by step. Find the size of the 2 white tails on the end, because that's outside the confidence interval. To do that, first I have to figure it out. If they want a 90% confidence interval, like on this one, I do 1 minus 0.9, gets me 0.1, and I cut it in half because there's 2 white areas on either end. Well, 1 on either end, 2 total. Second var is inverse norm. Whatever I've calculated for that area, 0.05, then 0.1 is z-score mode. That gives me 1.645. Error bound measurement. You're given the formula. You don't have to memorize it. I take whatever my answer is to second var's inverse norm, which is 1.645, and I multiply by the standard deviation divided by the square root of the sample size. That gives me 1.4. Then you just go up there and you say, look, the green is on either side of the mean. The mean is 36, so I'm going to do 36 minus 1.4 and 36 plus 1.4. That gives me my 96% confidence level. I do want to take a moment to emphasize that this error bound, the second half of the error bound formula, the standard deviation over the square root of n, that's the same SE, if you will, that you use in the central limit theorem, okay? The standard error. Okay, so now let's do the same exact problem, but with an 80% confidence interval. So now, for the first time in this series of lessons where I've taught and talked a lot, where to stop-start mode. You do this with stop and start. And if necessary, go back and watch a short section of the video before this to help you out. Go ahead. Okay, so now, again, first thing we need to know is what's the mean, what's the standard deviation, what's the sample size. So we said the mean was 36, the standard deviation was 6, and the sample size was 50. If for some reason you didn't recall that from the previous problem, pause now, do your stop and start. And then once you're done, start up again and you can catch up with us. Okay, so it wants an 80% confidence interval level. So, oh, there's my error bound formula again. Okay, so the area of the whole normal curve is 1. I got to subtract the 0.8 for the 80% interval area. That leaves me with 0.2. Divide that by 2 for the 2 white ends, 2 white tails, if you will. That's 0.1 each. Now, I need to do second var's inverse norm of that 0.1 in z-score mode, 0, 1, and I get 1.282. You punch it in your calculator, that's what you'll come up with. Okay, well, what do I do with that? Well, that is the beginning of my error bound measurement formula. So I calculate with error bound measurement. I have everything I need now. I have 1.282 for the z-score for that area. And then I have the 6 over the square root of 50, which is your standard error. And that gives me, when I multiply that all out, 1.09. What do I do with the 1.09? Well, that's got to surround the mean. So I get 36 minus 1.09, which is 34.91, and 36 plus 1.09, which is 37.09. That means that the 90% confidence interval level is from 34.91 to 37.09. We express that with parentheses and the comma in between, kind of like a coordinate. Okay? Let's do one more problem here. And this problem is a really cool problem because you're actually going to come to 3 different problems within the same problem. So I am going to pause. At this point, I'm going to stop this video and we'll pick up the next video on this one because there'll be 3 similar in a row and I'm not going to want to break them up.